All right, guys, welcome to video 2, surface finish measurement. So to define a surface finish, it's basically the surface texture of a machine part. And if you remember from the degradation of workmanship principle, every time we add a new process to machining or a new type of machining method to an existing process, we're contributing more potential error and losing accuracy. And since no machine, no process is ever going to be perfect, we're always going to have errors. So these errors are known as asperities, and asperities are basically the unevenness or roughness of a surface. Now in your textbook, section 2, unit 4, asperities are discussed, and two specific asperities, and that would be waviness and roughness. But there are really 4 different types that we can consider. Error of form is really the combined effects of roughness and waviness, and flaws. Think about error of form. If we're trying to get something extremely flat, it's pretty much impossible. Our world is round, and flatness is unnatural, so it's a tough thing to try to create. Flaws, well, I think they speak for themselves. Imagine you're working in a facility or a shop where there is a large press, and when that press comes down and stamps something, let's say, for instance, it makes a lot of vibration, and that vibration results in chatter in a tool bit. And based on that chatter, we may have some surface imperfections in specific locations of the surface. Flaws are going to be pretty easy to detect because they're going to stand out from the roughness of a surface. Basically, every machining method is going to create a different type of roughness. For instance, let's say we're doing a lapping process. That roughness is going to look much different than if we were to laser cut that surface. So we'll talk more about that in just a moment. So now lay is basically the byproduct of the machining process itself. It's the direction of the asperities. So depending on what types of cuts we're making and how, it's going to determine basically the direction of the roughness of the surface as well as its waviness. So here's an example of different types of lay. If you notice, you can see there are symbols as they're called out and also what they would look like. So for instance, circular cuts might look like C. Now let's talk specifically about 2 different types of asperities, and that's roughness. Roughness is essentially the peaks and valleys left by cutting. And if you look at the image, you can see that roughness height. Now, we're going to talk a little bit about how we gauge this surface roughness, but we do it using RA, which is basically our arithmetic average. And the way we're measuring these things is in micro inches or microns or micrometers. We're talking about very, very, very fine imperfections in a surface. You're going to notice here they are amplified quite a bit just so we can actually visualize them. So what's the difference between roughness and waviness? Well, waviness basically tells us how roughness will change over an entire surface. So when we talked about gauge blocks a few weeks back, excuse me, my apologies, this would be true for gauge blocks, but a different example here. When we talked about surface plates a few weeks back, we talked about the fact that not only do different grades have different tolerances, but different size plates have different tolerances. That's because as the size gets larger, the potential for an error of form is going to be greater and greater because you are now looking at variation over a larger surface. So surface plates that are really big are going to have looser tolerances than smaller surface plates because we can reduce the variation when we are reducing the surface size. What types of tools do we use to measure these types of features? Well, we could use a comparator or a profilometer. So I will show you an example of one in a few moments. So let's talk a little bit about this roughness average, RA. This is used as a standard to determine the surface roughness. And be careful with the term average. It's not necessarily the mean like you would probably assume. First thing we do is we take the average of all these peaks and valleys, the highs and lows, the pluses and minuses, and we plot that average with respect to the highest and lowest points. So notice here, our average becomes our x-axis or our center line of this graph that you see here. So how do we calculate RA? Notice RA is going to be the distance from the average, or 0, our x-axis, to, well, this is going to be something a little different. What we're going to do here is we're going to not only add up the positives and the negatives, but instead we're going to add up the absolute value of all these individual variations from 0. And then we're going to take the average of those results. In doing so, we now have a new line. And the reason that we take the absolute values is so that whether we have a valley or a peak, we can show that that's a measure of variation. So we add up all the absolute values of these heights that you see here and divide by the number of points taken. The roughness average is the distance from the mean to all the average of all these absolute values of these distances. And that would be what's used to determine the surface roughness. In fact, if you were to look at a surface comparator, that's what you're looking at. So here are some examples of roughness average. And notice that they come in microns as well as micro inches. And be careful with this table. Notice that based on the process, we're going to see different variations in surface roughness. Our largest variation starting here, and we're getting smaller and smaller as we work our way down. This is a little unusual, as we usually see our graphs go from small magnitude to large. So if you notice here, if we look at sawing could potentially produce a rougher surface than something like reaming or laser processes would. So that's how we would read this table. So let's look at drilling. Notice that drilling, the worst surface roughness we could possibly encounter is 500 micro inches. The best surface finish we might encounter using this process would actually be 32 micro inches. Or we could say an average between 12.5 and 0.8 microns. So now these are the symbols that are utilized in this type of capacity. This is all the different ways you could see surface roughness called out. And imagine we were building a fabrication sheet where not only are we speccing out all of our part features, but also informing machinists or toolmakers on what type of surface finish we'd need. We would use these callouts in order to do so. So here's an example of a surface comparator. You can really see the difference between a rougher surface versus a much more precisely and accurately machined surface. The reflective properties change quite a bit. I think grinding does a really good job of that. As the surface finish becomes more and more accurate, in essence, as our RA gets lower and lower and lower, we can see the reflection in that metal, and that's just due to the accuracy of the surface. Now, here's a cool tool. This is a profilometer, and what this is doing is measuring the surface finish of this hole. Now, this machine knows the surface, the profile, and what it's going to do is electronically move across the surface and determine how many peaks, or excuse me, the level to which the peaks and valleys vary from the original profile of the surface. And that will allow us to determine the average roughness, RA, like we saw before, and make sure that it falls within specification. So that's it, guys. I just want you to keep in mind for week 10, don't forget about our tour. We've got our tour Tuesday at 4 p.m. We're going to meet at Hexagon right at that main entrance, and if you get there before me, you can walk right in and they'll sign you in. Don't forget to complete your homework worksheet, which is the course review homework worksheet. You can submit that electronically in Canvas, or you can complete that assignment and drop it off to me during our tour, or you can also complete that assignment and drop it off to my office. Whatever is most convenient for you works for me. Now, keep in mind what I'm going to do. If you'd like to complete your labs that we had begun and gotten through most of week 8, you're welcome to do so on week 10. That classroom will be open for you, and you won't need me there, so I can help out people in the lab, as your exam will be on Canvas and will be online. Keep in mind that your final exam will be due for Wednesday before 11:59 p.m. No exceptions there. If you have any questions with the course review homework worksheet or any general questions from this video, Don't hesitate to stop by my office during my office hours. I have office hours next week, week 10, from Tuesday, excuse me, my apologies, Tuesday from 1:30 to 5:30. I also have office hours Wednesdays from 12 to 1. If those don't accommodate you and you've got a lot of questions, just send me an email so I can connect with you and we can find a time that works for you. I hope you guys have a great week and I look forward to seeing you at the tour. Have a great one.